In this video, we want to discuss differentiation of implicit functions. An implicit function is a function where the dependent variable y is not given explicitly in terms of independent variable x. So it's not possible to write y in terms of x. So such a function can be written in the following format. In this video, we want to talk about how to obtain derivative of y with respect to x, dy dx. So let's start with something simple. Let's assume you're given a function like that. How do you determine dy dx? So you do term by term, meaning you differentiate each term with respect to x. So the first term is x, so the differentiation with respect to x is simply 1. Now the second term here is y. So what we are going to do, we are going to apply chain rule to this term. So this is quite simply dy dx, as we anticipate. And the third term here, you do the same. So chain rule, d dy cosine y dy dx, which will give you minus sine y dy dx. And of course the right hand side is 0 because the differentiation of 4, which is a constant with respect to x, is 0. So grouping them together, we end up with this line. Factoring out or solving for dy dx will simply give you minus 1 over 1 minus sine y, or simply 1 over sine y minus 1. So this is the result that we seek. Let's look at another example. So again, we will do term by term. So the first term is d over dy using chain rule, y squared dy dx. So that's going to give you 2y dy dx. So that's the first result. Now let's do the last one first. So that is simply 2x. When you differentiate x squared with respect to x, you get 2x. Now let's do the middle term. So middle term is that. Now what we can do, we can rely on product rule. So let's first differentiate the first term, which is minus 2y. And that's going to give you d over dy minus 2y dy dx. And then you just write down the second term. We are using product rule here. And then you write down the first term, which is minus 2y. And then you differentiate square root 1 plus x squared. And that's going to give you 1 over 2 square root 1 plus x squared times 2x. So 2x is what you obtain by differentiating the argument of that square root. So the answer for the middle term would be minus 2. When you differentiate minus 2y with respect to y, you get minus 2 dy dx square root 1 plus x squared minus, you can cancel these two 2's, and you're going to get 2yx over square root 1 plus x squared. So this is the differentiation result for the middle term. So after you put all the results together, you end up with this line. Now let's simplify it. Let's factor out dy dx from the first two terms, and that will give you 2y minus 2 square root 1 plus x squared. And let's factor the second and the third and the fourth term. You can take out the x minus x, so that's going to give you 2y minus 2 is over 1 plus x squared, and that's 0. Let's make the denominator of this term and that term to be the same, and that's going to give you 2y minus 2 square root 1 plus x squared over square root 1 plus x squared. So now you can see common terms. Let's take them outside or factor them out, and you'll get 2y minus 2 square root 1 plus x squared times dy dx minus x over square root 1 plus x squared equals to 0. And from the terms in the bracket, when you equate the terms in the bracket to 0 and solve for dy dx, you get the final answer, which is x over square root 1 plus x squared. So that is the answer that we are looking for. Problem 3. So let's apply the product rule to the first term. So I differentiate x, I get 1, and then I multiply cosine y, plus I write x, and then I take the derivative of cosine y, again using chain rule, dy dx. Now I do the same thing to the second term, and that's going to be plus d over dy minus y squared dy dx times sine x plus minus y squared, differentiating sine x with respect to x, you get cosine x equals to 0. Now realizing that this is minus sine y and that is minus 2y, we can rewrite the above line, cosine y, that's this term right there, plus, or minus rather, to include this minus from the start, x sine y dy dx minus 2y dy dx sine x, that is this third term, and final term is minus y squared cosine x equals to 0. So factoring out the dy dx, you will get minus x sine y minus 2y sine x, so that's this term and that term, equals y squared cosine x, I'm bringing this term to the other side, minus cosine y, I'm also bringing this term to the other side. And solving for dy dx, you'll get the following final answer. Cosine y minus y squared cosine x over x sine y plus 2y sine x. So this is the answer that we are looking for. Problem 4. So you have sine 2x plus 3y. The first thing is to rewrite this, just expand it using trigonometry identity. So sine 2x plus 3y is sine 2x cosine 3y plus cosine 2x sine 3y. So the left hand side, which is y, will simply become dy dx. Now the right hand side, you have two terms. Let's do term 1 and then we'll do term 2. We can do product rule for both of them. So first differentiate sine 2x. That's going to be 2 cosine 2x. And then you simply write down the second term, cosine 3y. The next thing is just write down sine 2x and differentiate cosine 3y. So that will be dy cosine 3y times dy dx. So that's term number 1. Now let's do term number 2. So you differentiate the first term in term number 2, cosine 2x. So that's going to give you minus 2 sine 2x. And you simply write down the second term, sine 3y, plus you write down the first term, and now you differentiate the second term using chain rule. So dy sine 3y dy dx. So this term here will simply becomes minus 3 sine 3y dy dx, and this term here will simply becomes 3 cosine 3y dy dx. So putting everything together, we will end up with 4 terms, 1, 2, 3, and 4. Now we have to rely on trigonometry identity again. We can combine these 2 terms to be 2 cosine 2x plus 3y, and factoring out dy dx from these 2 terms, and again using trigonometry identity, we will get dy dx 3 cosine 2x plus 3y. Then factorizing finally dy dx, factoring it out, you get 1 minus 3 cosine 2x plus 3y equals 2 cosine 2x plus 3y. And solving for dy dx, we will get the following as the final answer. So 2 cosine 2x plus 3y over 1 minus 3 cosine 2x plus 3y. So this is the final answer to this problem. Problem 5. So taking again the derivative with respect to x of the entire equation, the left-hand side of the equation will simply become dy dx. The right-hand side, when you take the derivative of 2, 0. Now we are faced with the second term. There are a couple of terms there, so product rule will give you taking the derivative of x is 1, so simply write the second term, plus write the first term and take the derivative with respect to x of the second term using chain rule. So simplifying it a little bit, you get ey plus x dy dy is simply ey dy dx. Now let's factor out dy dx. You're going to get 1 minus x ey equals ey, and solving for dy dx, you get ey over 1 minus x ey. So this is the final answer for this problem.